Good morning, class. How are you? Yes, I am fine. So, we are studying about the human eye and the colorful bird, and I hope you all are coming on time on online classes also. Now, this is the concluding chapter, and we'll finish it off today only, okay? And then we'll start the revision. And don't miss the revision classes, okay? Be on time, be punctual, ask your doubt from the teachers, okay? So, in this chapter we have read about prism, we have read about refraction. What is the new thing that we are going to discuss here? The new thing that we are going to discuss about here is called atmospheric diffraction. Okay, what is that atmospheric refraction? So refraction means what? When the light is bending, when the light will bend, when it will change the medium. Okay, when you will change the medium, this is density here in the last line, you just see only. Okay, when I will explain that time I will see this. Okay, so bending of light will get deviated, but how atmosphere will help this? In atmosphere we have air only, so medium is not changed. The doubt can come in your mind, but it is also changing. That what we change in that refraction, we change the density, and in the case of atmosphere we have also the change of density. Upside we have no air, we have vacuum in the universe, and when the sun rays starts coming from the universe, they reach to the earth's surface. That time we have a layer blanket of air, means the density has increased, means that is the reason why this atmospheric refraction takes place, and it is written here also. It is a deviation of light or other electromagnetic waves, means light is also a form of electromagnetic waves, forms a straight line as it passes through the atmosphere due to the variation in air density. This is here important point, air density. And that refraction is due to the velocity of light through air decreasing with increased density. Obviously when the density will increase, the speed of light will decrease. We have read all these things in the previous chapters, so this is what is there. Then through the figure, understand this here, light ray was coming, okay, it is coming here like this, and it will, so many layers are here, see. So as it will increase, the density of air will also increase. In that case what happens, the light used to bend and the position of the star from here to here changes here. This is the effect of atmospheric refraction. There are some more effects because of that atmospheric refraction, it is happening there. So first understand this, the change in the layer, this change, wait, change in the density of layer. Upside is vacuum, here it is vacuum, but when it reaches here at this point, a blanket of air is there, so that causes the light to bend, okay, and we able to see the object at some other place. Okay, what is the application, what is the other effects that atmospheric refraction can do? Atmospheric refraction can do these things. It can show you the sky is blue. Why the sky is blue? The gases and particles in earth atmosphere will scatter the sunlight in all direction. Obviously in all means we have air, so air has particles, that particles will scatter the light in all direction. In that case blue light is scattered more than other colors. Okay, why? Because it travels as shorter smaller waves, it has a moderate wavelength, because of that only. And when this blue color is scattered everywhere, so sky will appear blue only. See, sunlight was coming from there, all of a sudden, because the gas particles are present here, so it scattered blue color, and the whole sky looks like blue only. The whole sky will look like, means suppose this is the sky here, then this whole background will appear like blue only. Okay, so like this it will appear like this. That's why sometimes the sky appears blue. Then what are some other uses, what are the other applications of that? See that also. what its scattering does, that we see only there. See, this is one effect here. The sun is low. Now we'll see the delayed sunset and early sunrise. Okay, now sun is low on the horizon. Sunlight passes through more air at sunset and sunrise than during the day. Obviously, the sun has to travel more distance during the sunset, and because that time it is very far from us. Okay, when the sun is higher in the sky, it has to travel less distance, and that time sky appears blue only. And if that distance is long enough, then all the blue colors will scatter out from our eyes. And in that case, the sunset at the sunrise, sun appears either orange or red. Okay, red or orange. That is the reason. Okay, through the figure we understand this. All these 7 colors started from here. This is the sun. But as they reaches there, that blue colors is scattered earlier. But because the red color has longer wavelength, so it reaches at long distance here at the earth surface, and we are standing on this position, so we will see only the red color. That is why the sun appears in the morning or in the evening red or orange. Okay, see, early sunset and early sunrise is one more application of atmospheric refraction. Okay, what is that? Atmospheric refraction is the same reason that the sun is seen about 2 minutes before sunrise. Okay, when you are able to see sunrise, that means it's 2 minutes late there. Okay, and the same is for the sunset also. It is seen for about 2 minutes after sunset. Sun has set, but still sun is appearing. That means it is a delayed sunset, and that actual position of the sun is shifted from the actual position of the sun. Okay, it's slightly shifted. See, this is the actual position of sun, but it is appearing here at this position, so that causes the 2 minutes distance during the sunset as well as during the sunrise also. Okay, so one more application is there. This is here the position of stars. Because of that same reason where the sun we have been, this also happened the same due to atmospheric refractions. The actual positions, this is the actual position of a star, but when this light enters in the atmosphere, it bends and straight line becomes here and stars appears here. So this is because of atmospheric refraction. See, we have not changed the medium. We have not changed the medium. What we have changed? We have just changed the density of the medium. And that you have to keep in mind. Both are correct. When we will change the medium, light will bend. When we will change the density of the same medium, light will again change. Again it will change the direction. So refraction will take place. So this is what the cause is there. One more important thing is here, that now you revise all the topics. The syllabus has been sent to you, the revised portion. We will now start the revision. So be regular, be punctual, and don't miss the class. Thank you, class. Thank you very much.